In Precalculus Lesson 12, we start looking at rational functions. We'll begin with the definition, domain, and intercepts. This lesson is from section 3.1 in the College Algebra textbook. And let's start with the definition. A rational function is a function that is the ratio of polynomial functions. It looks like r of x equals p of x over q of x, where both p and q are polynomial functions, as long as q of x is not the zero polynomial. An example would be f of x equals 3x squared minus 5 over 7x cubed minus 2x squared plus 3x minus 1. Polynomials in the numerator and in the denominator. A non-example or a non-rational function would be g of x equals 3 square root of x plus 2, noting that 3 square root of x plus 2 is not a polynomial over x squared minus 5x plus 3. So find the domain first of the rational function f of x equals x plus 3 over x squared minus 16. The domain is going to exclude any values of x that would cause the denominator to be equal to 0. So note that x squared minus 16 factors into x minus 4 times x plus 4. Here we need to make sure that x is not equal to 4 and that x is not equal to negative 4. Our domain would include all other x values, so we have negative infinity to negative 4. Whoops, let me fix that. Negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. To find the domain of g of x equals x plus 3 over x squared plus 16, we look for values in the denominator of x, or values of x that would cause the denominator to be 0. There's no value of x that would cause x squared plus 16 to be equal to 0. So here our domain is all real numbers. And next we look at h of x equals x plus 4 over x squared minus 16. This function has the same domain as the first one we looked at. We just need to make sure that x squared minus 16 is not equal to 0. So our x values would include negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. There's a bit of a difference with this function that we'll take another look at in just a minute here, but the domain would be the same. Now we find the x and y intercepts of the function f of x equals x plus 3 over x squared minus 16. To find the x-intercepts, we're finding the values, a value of x that I would get here when the function is set equal to 0, when y is 0. Okay, so when we set y equal to 0, the only way that fraction can equal 0 is if the numerator is equal to 0 here. So we're looking where x plus 3 equals 0 as long as that doesn't cause the denominator to be 0. So as long as x squared minus 16 is not equal to 0, well, that's no problem here. If x equals negative 3, that does not cause the denominator to be equal to 0. So I have one x-intercept at the point negative 3, 0. For y-intercepts, we would set x equal to 0. We would have y equals 0 plus 3 over 0 squared minus 16, or negative 3 over 16, giving us the y-intercept at the point 0, negative 3 over 16. Now let's look at the function g of x equals x plus 3 over x squared plus 16. For the x-intercepts, we're looking for the values of x that would cause our function to be equal to 0. And the only way that can happen is if the numerator of x plus 3 is equal to 0. We need to double check that the denominator would not be equal to 0 for any x-intercepts that we find. And we would find that x equals negative 3 here. That does not cause the denominator to be equal to 0. So our x-intercept is the point negative 3, 0. For y-intercepts, we set x equal to 0 in our function. So we have y equals 0 plus 3 over 0 squared plus 16. Simplifying to get 3 over 16, we have a y-intercept of 0, 3 over 16. Now we have the function h of x equals x plus 4 over x squared minus 16. Let's see what the x-intercepts here would be. Setting y equal to 0, we'd have 0 equals x plus 4 over x squared minus 16. The only way that h of x would be equal to 0 would be if the numerator of x plus 4 is equal to 0. And we need to double check that when that happens, the denominator is not also equal to 0, so that we do have a defined function. So what if x equals negative 4 then? Oh, that would cause that denominator to be equal to 0. So in this case, we're going to have no x-intercepts. For y-intercepts, we would set x equal to 0. We have y equals 0 plus 4 over 0 squared minus 16. Simplifying to negative 1/4, we have a y-intercept of 0, negative 1/4. Okay, r of x equals 3 over x squared minus 16. For x-intercepts, we set y, or in this case r of x equal to 0. The only way that r of x would equal 0 is if the numerator equals 0. Well, 3 equals 0. I don't think that ever happens. So again, we have no x-intercepts. For y-intercepts, we set x equal to 0, giving us y equals 3 over 0 squared minus 16. Simplifying to get negative 3 over 16, we have a y-intercept of 0, negative 3 over 16. The try on your own for this first lesson is to find the domain and the x and y intercepts of the rational function r of x equals x minus 3 over x squared minus 9.